Okay, so today we're going to go over Earth layers. I'm going to start off by finishing the notes from yesterday. After that, I'm going to make a separate screencast of the brain pops in case you cannot access brain pops. All right, so looking at the layers of the Earth. Okay, so yesterday we went over the two main ways to separate the layers of the Earth. The first one would be the compositional layers. Composition means what is it made out of? In other words, the chemical makeup of the layers. So the first way we can divide the crust, or I should say the layers of the Earth, is by what is it made out of? The first layer being the crust. The crust is made out of mostly silicon dioxide. So when you pick up a rock, a major component of rock on Earth is actually silicon dioxide. Rocks are mixtures. They have many different things in them. There are many different types of rocks, but the major component of rocks on Earth is silicon dioxide. So that's the crust. Below the crust is the mantle. The mantle is actually the thickest part. And I keep improving on my notes as we go. These are actually my notes. I typed them up myself. The mantle is made out of silicon dioxide. Let me actually add some facts in here so we can say that the crust is the least dense layer. And then the mantle is actually the thickest layer. This is stuff I would be writing down if I was you, because I guarantee you stuff like this are test questions. So the mantle is the thickest layer. And then we have the outer core. The outer core is made out of nickel and iron, and it is a liquid. And the reason I didn't give you the makeup of the mantle is actually part of it is liquid, I should say a semi-solid, and then part of it is actually a solid. So the mantle, you can't really label like that. And then we have the inner core, which is made out of solid iron. So you can imagine a giant iron ball. I don't need that. Just throw it away. Just throw it away. Okay, so the inner core is made out of solid iron. Okay, so those are the compositional layers. If you're to study for a test on this subject, I would really go back and look at this slide. Okay, this slide right here has a lot of various test questions. In other words, you make a lot of test questions off this one page and the second page. So we can also divide the Earth into the physical structure. And I don't like this, I'm going to take it off. Okay, so the first layer of the Earth is the lithosphere. The lithosphere is the solid rock layer of the Earth. It's broken into tectonic plates. Okay, so the lithosphere is broken into tectonic plates. It actually consists of, if we go back to the compositional layers, it's the crust and the upper part of the mantle. And then once you get past the upper part of the mantle, it starts to turn into the asthenosphere. The asthenosphere is a semi-solid rock layer that flows slowly. You can think of it like hot asphalt. I also compare it to toothpaste. It's not a liquid, but if you squeeze it, it will flow. And then we have the mesosphere. And just to let you know, I've never seen a test question about the mesosphere. From what I remember, it is a solid. It's usually one layer of the Earth I normally skip over. But then we get to the outer core. The outer core is the liquid layer around the center of the Earth. And it's a liquid layer made out of iron and nickel. And then we have the inner core. The inner core is extremely dense. It's a solid because it's under so much pressure it's been squeezed into a solid. And it is also the hottest layer of the Earth. Okay, So not only does the density increase as you go down, but also the temperature of the Earth increases as you go down. Okay, then we have, going through the different sections. The what? Okay, I'll go look at it. I believe, yeah, I'll go, remind me before you leave class. I'll go make sure I do it. All right, so then we have the lithosphere. The lithosphere is the solid rock layer of the Earth. It consists of the crust and the upper layer of the mantle. It has two parts. It has the continental crust and the oceanic crust. The continental crust is the light brown section right here. It is made out of granite. And then the oceanic crust is the darker stuff, darker brown down here, and it is actually made of basalt. Basalt is a very dense, heavy rock. The lithosphere is broken into tectonic plates. These plates float on a soft, semi-rigid asthenosphere. All right. So again, you can think of the lithosphere as floating on top of the asthenosphere because it's less dense. Things that are less dense float, and the asthenosphere is a semi-solid. And the theory is that is why the tectonic plates are moving. Okay, the asthenosphere is a semi-solid that can melt rock. It has plasticity, is the name of it, and can flow like a liquid. I'm sorry? Yeah, I don't see you here. Okay, so another good test question. See these arrows right here? These are convection currents. If you remember from our heat unit, conduction is heat transfer by touch. Convection, hot air rising, cold air sinking, or water. And then radiation was light. Well, these are convection currents. And it occurs from hot magma rising, cold magma sinking. Okay? The theory is this movement is what drags the tectonic plates along. Okay, so I would, if you have a notebook, maybe draw a little pie-shaped thing, draw these arrows, and label them convection currents. That's another very good test question. In fact, I'm always surprised when students get that wrong, so we'll be talking about those over and over and over for the next 2 weeks. And then here comes a test, and I have students that don't know what convection currents are. So convection currents are hot magma rising, cold magma sinking, and the theory is that's what drives the tectonic plates along. Okay, then we have the crust. The crust is the coolest, outermost layer. It is the thinnest layer of the Earth. It's made out of mostly silicon dioxide. It's divided into two parts. The continental crust, which is less dense but very thick, and it's made out of granite. And then we have oceanic crust, which is very dense and thin, and it's made out of basalt. I would highly recommend that you write down that. Continental crust is made out of granite. Oceanic crust is made of basalt. Continental crust is the land that we walk on. Oceanic crust is the ocean floor, and it also extends below the continental crust. This becomes very important when we talk about plate tectonics, because what happens when continental crust and oceanic crust collides, the oceanic crust goes below the continental crust because it's so dense, it's so heavy. Okay, so here it is. Oceanic crust does what's called subducts under continental crust. This is a picture of granite. It is what continental crust is made out of. Are y'all familiar with granite? Where do y'all know granite from? Anybody? Justin? You're not familiar with the word granite? Yeah, exactly, Corey. Yeah, tabletops, right? Countertops. Yeah, if you have granite countertops, that's the kind of the good fad, or what do you call it, the newest fad, last 10 years or so. Like they used to have the fake wood countertops, well now, granite countertops. So this is if you in your kitchen, or if you go to a restaurant, or in your kitchen, if you have granite countertops, if you take this stuff and polish it, it's actually really pretty. This is a rough piece of granite, hasn't been polished. Comes in all different types of colors and shapes. Granite is actually made, it's called a intrusive igneous rock. It's actually made from lava cooling very slowly underground. How many of y'all have ever been to Enchanted Rock? Y'all been to Enchanted Rock?
I'm going there next Sunday.
Are you? Yeah, it's a very crowded area. I actually, I think, that's on my other slideshow. I actually have a picture of me taking high school kids on a field trip to Enchanted Rock. Last time I went to Enchanted Rock, we actually didn't go. We pulled up on the highway. Let me do it like this. I should be showing a full screen. Last time I went to Enchanted Rock, we actually pulled up on the highway, and they look like ants. Just so many people. Look like dozens of little ants crawling all over. Anyways, I have another slideshow I'm going to show you in a couple weeks. I think it's in my rock presentation, where I have pictures of me on a field trip there with high school kids about 10 years ago. Anyways, this is a giant outcrop of granite. In Texas, below our feet, we have limestone. Limestone is actually rock that's made from dead sea organisms. And what happened here is the limestone eroded away from a granite outcropping. So this is a giant granite rock. This is basalt. It's made out of this is what oceanic crust is made out of. These right here, these pillars, I forgot the name of them, but that is basalt. This is where magma from deep in the earth has squeezed up into a volcanic vent, and that's actually this thing right here, which is called Devil's Tower. This is actually a volcano. What happened is millions of years ago, lava squeezed up into a volcano, and then what happened is the land around it eroded, leaving the inside of the volcano. So this is the inside cone of the volcano. And this is a close-up picture of it. Pretty cool. I actually went there, and again, I think I have a picture of me standing next to this thing in another presentation. All right, this is basalt at the bottom of the ocean floor. You see these scrape marks on it? That's from where it oozed out between the crust of the earth. So these are called pillow rocks, and they can actually date these. These are some of the newest rocks on Earth. They're located near an area called seafloor spreading, near a mid-ocean ridge. All right. The mantle is the middle and the thickest layer. The middle mantle flows because of convection currents. Convection currents are caused by the very hot material at the deepest part of the mantle rising and then cooling and sinking again. The mantle has plasticity, which means it flows. All right, so going from inner to out, outer core is liquid. This is kind of just a review. Inner core. Okay, we'll go over these videos tomorrow. Let's go ahead and start brain pop. So from here, we're going to go to brain pop. You should have joined my class yesterday. Did everybody get a chance